Welcome to NASA's Jet Propulsion Laboratory in Southern California. NASA's Ingenuity Mars helicopter hitched a ride to the Red Planet on the Mars 2020 Perseverance rover, which landed in Jezero Crater on February 18th. Now, the rover is getting ready to drop the helicopter off so it can attempt the first powered, controlled flights on another planet. Today, we'll bring you up to speed on the team's plans. I'm your host, Raquel Villanueva. To tell us about the upcoming milestones and the helicopter's test flights are Lori Glaze, Director of NASA's Planetary Science, Bob Balaram, Ingenuity Chief Engineer, Håvard Grip, Ingenuity Chief Pilot, Farah Alibay, Perseverance Integration Lead for Ingenuity, and Bobby Braun, Director for Planetary Science at JPL. For anyone watching who'd like to submit a question, you can do so by using the Mars helicopter hashtag. Our phone lines are now open to the media, and you can ask questions by pressing *1 and enter the queue. To start, I'd like to welcome Lori Glaze. Thanks for getting us started, Lori.
You bet. Thank you, Raquel. We're here today to celebrate great engineering achievements that required hard work, perseverance, and above all, ingenuity. The Perseverance rover carries with it the most advanced suite of science instruments we've ever sent to Mars, as well as several technology demonstrations, including the Ingenuity helicopter. Perseverance and Ingenuity are all of NASA missions, and by that I mean they cut across science, technology, human space flight, and aeronautics. In fact, when the decision was made to add a small helicopter to the Mars 2020 rover mission, the Jet Propulsion Laboratory looked to our Aeronautics Research Mission Directorate for their expertise in rotorcraft aerodynamics. A small team of NASA helicopter experts assisted JPL in verifying that Ingenuity could fly in Mars's super thin atmosphere, and they also helped analyze the helicopter's design. When I reflect on Perseverance and Ingenuity, I not only think about the future science and possibilities that'll be enabled by these two engineering marvels, but also about those two words and how they represent the core human characteristics that got us where we are today. The very first wheeled rover vehicle to rove on another planet on Mars in 1997 and paved the way for a new era of Mars exploration. Sojourner redefined what we thought was possible on the surface of Mars and completely transformed our approach to how we explore there. That small rover enabled all the missions to follow. The size of a small car is able to carry other technology demonstrations like Ingenuity, which will further expand our horizons. At NASA, we strive to anticipate what scientists are going to need to do great science in the future, and the technology demonstrations by their very nature do this. It's a high-risk, high-reward approach that allows us to test capabilities we can improve on later, which could also advance science on future missions. Ingenuity is a limited time project. It will have 31 Earth days to attempt to be the first helicopter to fly on another planet. It isn't intended to collect science, but because its mission is so focused, it is, at its core, innovative. And that innovation is the heart of tech demonstrations. Another technology demonstration on board Perseverance includes MOXIE, which will test technology to convert atmospheric carbon dioxide into oxygen, which could help us enable human missions to Mars in the future. Tech demos related to the rover's entry, descent, and landing, like range trigger, allowed for precise timing of parachute deployment and helped us to avoid hazards on landing day. An earlier demonstration of the Medley technology for Curiosity to advance our understanding of atmospheric entry during the Perseverance landing. And beyond tech demos, Perseverance is loaded with other amazing technology integral to its science mission, including a complex sampling and caching system that will drill for samples of rock and soil to be collected by our future Mars sample return missions. Ingenuity will open new possibilities and will spark questions for the future about what we could accomplish with an aerial explorer. Could we image areas not visible from space or that a rover couldn't reach, like shadowed craters with seasonal water flow? Could a helicopter scout ahead for rovers and help plot the most efficient course for the best science? Could we support future human missions with aerial capabilities? Demos give us the leeway. Those are questions for another day, but tech demos give us the leeway to be creative and test new things. And without Sojourner, there is no Perseverance. And without Ingenuity, there wouldn't be the future aerial explorers we're hoping will be enabled by the coming months' flight. We're looking forward to seeing how our little helicopter does on the surface of Mars. And we know people around the world are eager to join us for that exciting 31-day demonstration. To tell us about and now I'm going to turn it over to Bob Balaram to tell us about some of the engineering milestones that made it possible for Ingenuity to reach Mars. We've already learned a lot just through that process.
Could I have the first image, please?
Bob?
Yes. Thank you, Laurie. So when we see this image of Ingenuity, yes. So when we see this image of Ingenuity, what comes to my mind is that it's really a first unique aircraft designed to fly. Of all planets, it's Mars, flight on another planet. Thinnest atmosphere. And of all planets, it's Mars, which has the thinnest atmosphere, just 1% of Earth. And it's a very unique engineering design with its 4-foot diameter blades, counter-rotating blades, that's little solar panel on top, electronics, and a fuselage that's filled with all kinds of electronics, everything from advanced carefully tailored items to off-the-shelf items, all carefully tailored and screened for use on Mars. It's a very unique with the aircraft that is capable of that kind of flight, with the blades spinning at 40 RPM, and really being able to take off in 40 times a second, and really being able to take off in that thin air of Mars. This is in effect. But I also see a spacecraft. This is in effect an aircraft that also happens to be a spacecraft. It has survived launch. It has survived the journey through space, entry, vacuum, and radiation onto the surface. It has survived the entry and descent and landing onto the surface with its on the bottom of the Perseverance rover. And it has survived all the challenges and design issues that are necessary for a spacecraft. But most of all, I think of Ingenuity also as an experimental aircraft. Here, experimental aircraft. The long tradition of experimental aircraft who are able to start all the way from the Wright brothers, who are able to bring aerial mobility, travel here on Earth, dimension for us to be able to travel here on Earth. Ingenuity also in the same way we are hoping that Ingenuity also allows us to expand and open up aerial mobility on Mars. Now, the Wright brothers in 1903, they flew this with spruce wood and fabric. Small spruce wood and fabric with all our high-tech materials and carbon fiber. We in Ingenuity with all our high-tech materials and carbon fiber skins and exotic metals. We are very proud to honor that by carrying a small experimental aircraft from long ago. By carrying a small piece of fabric. Here you see engineers installing Ingenuity. Here you see engineers installing that small piece of fabric. Is from the original aircraft that flew at Kitty Hawk. Is from the original Kitty Hawk. Of this to raise money for their the Wright brothers were auctioning pieces of this to raise money for their future efforts. And we thank the folks at Dayton History who let us honor that original pioneers with this aircraft. Adding this piece. It has been a long journey. Ingenuity aircraft. And everything from it has been a long journey. Test programs that had failures everything from days. Test programs that had failures in the early all the way culminating days, and you can roll the video. Actually building all the way culminating Ingenuity flight actually building that is flight worthy and can Ingenuity flight model we have that is flight worthy and can go to Mars. Everything we have done a lot of testing to everything from into our the mechanisms space chamber, which simulates going into our 25-foot space chamber, which simulates the atmosphere of Mars, the performance of where we did a number of flights to characterize the performance of the system, and to understand how well it can control itself, maneuvers and to make sure that we knew how a whole number of maneuvers to make sure that we knew how this thing could fly here on Mars. A lot of testing has been done. Everything that we could possibly do here on Earth has been done, and now it's time for us to take that same vehicle to Mars and subject it to the ultimate test ahead. There are still a number of challenges ahead. Now where we are on the surface. At a milestone right now where we are on the surface. We have successfully exposed ourselves to the atmosphere of Mars. Drivers to a location. We are right now in the process of having the rover drivers to a location, which will be our airfield. There will be a long 10-day sequence of careful critical deployments. And then there will be the deposition of the helicopter on the surface. And then there will be that first exposure to sunlight when we have to charge the batteries by ourselves. We were no longer part of the Perseverance rover and connected safely. And we're completely on our own, fully autonomous, waiting to receive commands. We will go through a number of days of commissioning, approximately a week, where we test out sensors, we test out servo mechanisms, and we'll be very methodical motors to make sure they spin right. And we'll be very methodical and even-driven as this engineering experiment unfolds. We will undertake our first flight. We will be at a point where we'll undertake our first flight, and then we'll progressively undertake more aggressive flights once we understand and analyze all the behavior from that first flight. Who will tell us more about. So with that, I would like to turn it over to Håvard, who will tell us more about our first flight.
I want to talk a little bit about where we've chosen. I want to talk a little bit about where we've chosen to fly the helicopter. The rover landed on February 18th. Immediately after just within a couple of rover landed on February 18th. Just within a couple of hours, we started to search for a good place. And when I say good place, what I mean specifically is we wanted to find. And when I say good place, what I mean specifically is we wanted to find something that we call an airfield, which is an area where it is safe for the helicopter to take off. And also safe for the helicopter to land again after a flight. And it needs to have few obstacles. So that area naturally needs to be flat, and it needs to have few obstacles, rocks and the like, that could pose a danger. And that area should also be situated within a larger flight zone. And that area should also be situated within a larger flight zone. And we're also looking for something where the flights themselves will happen. And we're also looking for something relatively flat there. Enough texture. And we're looking for something that has enough texture. Can look at with its cameras while it's flying. Things that the helicopter can look at with its cameras while it's flying in order to keep track of where it's at. So we began to look for an airfield and a surrounding flight zone. And then as it became available, first using images taken by the rover itself. And then as it became available, images taken by the rover itself. And we began to realize that we might just have a really great airfield right in front of our noses. If we can pull that up. In fact, we have a satellite image, if we can pull that up, where the rover landed, as well as the flight zone and the airfield. Where the rover landed, as well as the flight zone and the airfield. And you can see it's just right north of where. And once the rover started driving, we were able to get even better images of this area what the rover saw. And we have a second image here that shows what the rover saw with its navigation cameras looking directly up the airfield. Or up the flight zone with the airfield these images in the foreground. And other images. And using these images and other images, we really scoured this area. We looked at every little rock and pebble within that airfield and measured it before we finally were comfortable saying, yes, this is going to be our home base for the helicopter. Is in fact the first. So what you're looking at there is in fact the first airfield on another planet. In the middle of that. And we're planning to deploy the helicopter right in the middle of that. So next I want to talk a little bit about our first flight and what that's going to look like. So next I want to talk a little bit about our first flight and what that's going to look like starting from this airfield. The first flight is special. First of all, the first flight is special. It's by far the most important flight that we plan to do. By an aircraft on another planet. It'll be the first powered flight by an aircraft on another planet. Most of our goals for this project. And we've in fact met most of our goals for this project just by getting to the point where we are right now. If we do this first flight that we're going to attempt. Will consist of a takeoff. Now the flight itself will consist of a takeoff and then a climb to an altitude of 3 meters. And then we will hover in place. Turn with the helicopter for about 30 seconds and make a turn with the helicopter while we're hovering. And then come down and land. Engineering simulation here that shows when we have an engineering simulation here that shows airfield what that flight might look like above the airfield that we have just chosen. When the helicopter goes to fly like this, now, when the helicopter goes to fly like this, a few hours ago, it's already received instructions from us on Earth that describes exactly what the flight should look like. The detailed trajectory that it's going to follow, how fast it's going to follow that trajectory, when it's going to take picture, where and when it's going to turn, when it's going to take picture, etc. We would like it. So it knows at that point exactly what we would like it to do. During the flight itself, in order to make that. It has to work very hard during the flight itself in order to make that happen. The ground below it, in particular. It takes images of the ground below it at a rate of 30 images per second and analyzes those in order to track the features on the ground to see how it is moving. And it combines that with other sensor measurements in order to make tiny adjustments to the controls 500 times per second to stay exactly on the trajectory that we prescribed for it and to fight off disturbances that tries to take it away from that trajectory, like winds and gusts. Turn it over to Farah, who's going to talk about how the rover will be supporting the helicopter during the flight.
I'm going to be talking to you a little bit about how we get from where we are today to that first flight early in April, and how the rover team is supporting the Ingenuity mission. I love this picture. So if we look at our first picture here, I love this picture. We took this on Mars using our robotic arm. And what you're looking at here under the belly of the rover. And what you're looking at here is the debris shield on the ground. That's the debris shield that protected our helicopter as we were landing on Mars last month. But what's the coolest thing is you can see Ingenuity there, all tucked in below the rover, doing okay. Everything is all in place. And she's ready to get to the surface of Mars. So what's going on right now is that we're driving to that helicopter deployment area that Håvard just talked about. That's going to take another couple of days. And then when we get there, we're going to go through a series of steps to get the helicopter from its current horizontal position all the way to being vertical and then being dropped on the ground. That's a very prescribed and meticulous process where we separate, there's a number of launch locks and attachments that we separate one by one. We're going to be imaging each time, making sure that the helicopter is in the expected position before dropping it on the ground. So that's going to take multiple days. With the most stressful day, at least finally for me, is going to be that last day where we finally separate the helicopter and drop Ingenuity on the ground. And if we queue up the video here, you can see the testing that we did in the Mars yard, which is our version of Mars here on Earth, where we do all our testing, where we drop the helicopter and backed away from it very slowly. So on that last day, we released the last restraint, slowly drive away from the helicopter, making sure that we don't hit it or anything. And what's most stressful is that once the helicopter is separated, we actually have to drive away from it within 25 hours. As Bob mentioned, the helicopter needs photons, it needs sun on its solar panels to charge its batteries, and it can only survive one Martian night without that. But what I look forward to so that's going to be a very stressful period, but what I look forward to the most is after we do that drive, we're going to get that first shot of Ingenuity on the surface of Mars on her own there, and I just cannot wait to get that first picture. I think it's going to be really great. So after we've dropped Ingenuity on the ground, as Bob mentioned, through a series of commissioning steps, right? Wiggling the blades, doing a bunch of checkouts. From our end, the rover is going to slowly be backing away, imaging Ingenuity every step of the way to what we call the rover observation location. Think of it as a lookout point. Like if you ever go to a national park and you have a beautiful view, you want to park there and look. Our rover is going to do that, and our beautiful view is going to be Ingenuity. And we are going to do our very best to capture Ingenuity in flight. We're going to be taking images. We're hoping to take video. Now I'm going to warn you, it's hard. Space is hard, and in this they have their own separate clocks, and we got to get that timing right to get that first flight. But we're trying very, very hard to catch that and get that. Wanted to give you a little bit before I hand it over here, I just wanted to give you a little bit of an anecdote, a little bit of a personal side to this. So on the rover side, we're kind of a small team supporting the Ingenuity team. All of us have our own day jobs supporting the rover mission itself, and all of us were asked at some point, hey, call where can you help make this mission happen? I still remember the phone call where I was told, hey, Farah, we know you're busy, but there's this helicopter. Do you want to help with operations? And of course, my answer was absolutely yes. And it's been such fun. It's been an honor for Håvard and Bob. It's been an honor for our team and to be able to support you and your team and to be part of this historic event. I really appreciate you, and I just cannot wait to spend the next 40 or so days with you here, getting Ingenuity on the ground and supporting
Farah, the entire giving us Mars 2020 Perseverance team for being so helpful and giving us this precious month on Mars.
Absolutely, it's been a great collaboration, and absolutely, it's been a great collaboration. And so with that, I'll hand it over to Bobby, who's going to tell you a little bit more about the team and wrap things up.
Before I get started,
thank you.
I just wanted to say a little bit.
Before I get started,
community.
I just wanted to say a little bit about my
I've been at
former community
JPL for about a year now,
Boulder.
and prior to that,
I've been at JPL for about a year now, and prior to that, I had the privilege of serving as the Dean of Engineering at the University of Colorado Boulder. And I just want to say that, from all of us here, that our hearts go out to that community today.
One of which
Boulder's a special place for many reasons, and one of which is the connection to aerospace.
In fact, JPL has many partners
space exploration
across Colorado.
In fact, JPL has many partners in Boulder and across Colorado.
The faculty and staff that
so to my former students
and the whole Boulder
the faculty and staff that I worked with every day and the whole Boulder community,
and know that
I just want to say that we stand with you and know that you'll get through this.
This past year,
thank you.
Our world and the lab has largely been about perseverance.
Our world and the lab has largely been about perseverance. But as we approach April, while we continue persevering,
Ingenuity.
it feels a lot to me
And it's Ingenuity
like the month
and
of
this
Ingenuity.
And
it's Ingenuity
and this team
in April that are primed to make space history in April, marking humanity's Wright brothers moment, the first flight of a powered craft on Mars.
For the helicopter.
Ingenuity is an apt descriptor for the helicopter,
closely,
but also for this team.
Resourceful,
I've watched them closely.
creative,
They're close-knit, resourceful,
a diverse
creative,
team of innovators.
imaginative,
And I want to take just a moment
diverse
on behalf
team
of
of
the lab
innovators.
to thank
And I want
the
to
whole
take
team
just a
for
moment
what
on
they've
behalf of the
already
lab
accomplished,
to
what they've
thank the
already
whole
taught
team
us
for what they've
about
already
perseverance and
accomplished, what they've
ingenuity
already
as
taught
they
us
traveled the road
about
to Mars.
perseverance and ingenuity
Now, this
as
team
they
would be the
traveled
first
the
to
road
tell you
to
that
Mars.
while they may be
Now,
able
this
to
team would be the
fly
first
in a
to
near
tell you
vacuum,
that while they may be able to fly in a near vacuum,
and in fact, we've
they
had a
couldn't
great
build
set of
ingenuity in one.
partners in this
And in
endeavor.
fact, we've had a great
with their
set
deep
of
knowledge
partners
of
in this endeavor.
rotorcraft,
With
the
their
NASA
deep
Ames
knowledge
Research Center
of
has been a source of
rotorcraft,
invaluable
the NASA
assistance
Ames
to this
Research
project.
Center has been a source of
NASA Langley
invaluable
Research
assistance
Center
to
made
this project.
significant contributions
NASA Langley
in the area of
Research Center made
computational
significant
fluid dynamics.
contributions
And
in the area of computational fluid dynamics. And in addition, I'd like to thank some of our partners at AeroVironment, at Qualcomm,
As Dr. Glaze
and at
mentioned
Lockheed
earlier,
Martin.
Ingenuity
As
is a
Dr.
tech
Glaze
demo.
mentioned earlier,
And historically
Ingenuity
speaking,
is
it
a tech
wasn't that
demo.
long ago
And
that
historically
another
speaking,
Martian
it wasn't
tech
that
demo
long ago
was assembled
that
in a
another
clean room
Martian tech
only a few
demo
hundred meters
was
from where we
assembled
are
in a
today.
clean room only a
Sojourner.
few hundred meters from
Sojourner
where we are today.
demonstrated the value
Sojourner.
of surface mobility.
Sojourner demonstrated
And
the
that tech demo
value
mission
of
was
surface
followed
mobility.
by the great
And that
scientific
tech demo
discoveries
mission was
of
followed
spirit,
by the great
opportunity,
scientific
and
discoveries
curiosity.
of spirit,
Now we've
opportunity,
added the
and
name
curiosity.
of perseverance to that
Now we've
impressive list.
now added the name of
A series
perseverance
of
to that
increasingly
impressive list.
sophisticated
A
science
series of
emissaries
increasingly
that have advanced
sophisticated
our knowledge of
science
Mars and
emissaries
taught us a little
that have
bit more
advanced our
about our
knowledge
home
of
planet
Mars
Earth.
and taught us a
They
little
brought
bit
Mars
more
home
about
to
our
all
home
of us.
planet Earth.
And to think,
They've brought Mars
it all
home
started
to
with a
all of
tech
us.
demo.
And to think, in this
It all
same
started
spirit,
with a
I
tech
can
demo.
only imagine
where we may
in this
be a
same
decade
spirit,
or
I
so
can
from
only
now.
imagine
If we
where we
can
may be
scout
a
and
decade or so from
scientifically
now.
survey
If
Mars
we can scout
from the air
and scientifically
with its thin
survey
atmosphere,
Mars from
we
the
can
air
certainly do the
with
same
its thin
in a number
atmosphere,
of other
we
destinations
can certainly
across
do the
solar
same
system,
in a
like
number of
Titan
other
or
destinations
Venus.
across the solar system.
We can provide
like
higher
Titan
resolution
or
measurements,
Venus.
perhaps from
We
orbit.
can provide higher
fly
resolution
farther,
measurements, perhaps from
than a
orbit.
rover could traverse,
Fly
or
farther,
access sites
perhaps,
that are
than a rover
difficult,
could traverse,
to reach
or
by
access
these other
sites that are
means.
difficult
The future
to
of powered
reach
flight
by these
in
other
space
means.
exploration
The
is
future
solid
of powered
and strong.
flight in space exploration
Now,
is
I'd like
solid and
to
strong.
take a moment to talk
Now,
about
I'd like
the location
to take a moment
that Perseverance is
to talk
headed
about the
towards.
location
and
that
from which it
Perseverance
will
is headed
watch over
towards,
Ingenuity's
and from
historic
which
flight.
it will watch over
The team has
Ingenuity's
decided to name
historic
this
flight.
location on Mars in
The team
honor
has
of our
decided to name
longtime
this location on
colleague,
Mars in honor of
mentor,
our
and
longtime
leader here at
colleague,
JPL,
mentor, and leader here at JPL. Jacob passed away unexpectedly in August of 2020. About a month after in August of 2020. He joined a month after the Perseverance launch. He joined JPL in 1986 and served crucial roles over a 33-year career that touched nearly all aspects of the science operations that we conduct at JPL. From ushering in the use of synthetic aperture radars for Earth science, to leading the teams responsible for making breakthrough discoveries in the cosmos, Jacob was a Renaissance man. He seemed to do it all. He contributed to the success of the Spitzer and Kepler space telescopes, to Juno's mission to Jupiter, to the Dawn mission to the asteroids, Cassini to Saturn, and InSight Mars lander. Jacob was also a pioneer and an innovator himself, who helped develop the Marco mission, which were the world's first interplanetary small spacecraft, which flew as a tech companion along with the InSight lander. When Ingenuity was conceived here at JPL, it was Jacob who pushed this team forward. Jacob came to America in 1982 as a graduate student at Caltech, where he earned a master's and PhD in electrical engineering, and he began to work at JPL immediately thereafter. He was passionate about sharing the excitement of space exploration with the people of Namibia, across Africa, and across the globe. With his wife, Calfee, he returned again and again to his homeland to conduct STEM outreach on behalf of the space program. Now, Jacob was a dear friend, a mentor, and a devoted teammate to me and to all of us across JPL. It remains hard for many of us to imagine our community without his light and smile. Ingenuity was one of Jacob's final projects at JPL, and it would not exist today without his leadership, dedication, and patience. He was the guiding force watching over this team, and he would have been so proud to see the product of this team's hard work. On behalf of all of us at NASA, at Caltech, and at JPL, and in particular on Ingenuity teams, it's my honor. We are recognizing Jacob's sustained and significant contributions to space science by naming the location on Mars from which Perseverance Ingenuity's historic flight as the Van Zyl Overlook. May he continue to watch over this team, and may his memory continue to guide us, encourage us to be bolder and dare mighty things. Thank you, Raquel. Back to you.
Thank you for that beautiful tribute, Bobby. And we are now ready to take media questions. Remember to press *1 to get put in the queue, and please direct your questions to one of our panelists. We're also taking questions through the Mars helicopter hashtag. To start off on the phone lines is Marcia Dunn from the Associated Press.
Yes, hi, good afternoon. Two quick questions. Could I have a little bit of a timeline in April as to when you think you'll be meeting your milestones, and what target date at this point, no earlier than date, do you think the first flight might occur? And the fabric sample from the Wright Flyer, could you tell me how large of a piece of sample that is that flew on Ingenuity? Thank you.
You take that, Bob?
Yes, let me take that. So our current best estimate of when the flight could happen is no earlier than about April 8th. But things are fluid. As I mentioned, we are very event and experiment driven, so that could be changed by a few days in either direction. But that's the best guess that we have right now is April 8th. The piece of fabric is about the size of a postage stamp. And so it's really a small little element that's been sealed and wrapped in appropriately, and it's been attached to a small cable on the underside of the solar panel. And it's called Pride of the West. That's the kind of fabric that was used on the original flyer. And that's what's there on Ingenuity right now.
Great, and up next we have Bob Brinkman from UPI.
Hi, yeah, this is Paul. I was wondering, I know NASA doesn't like to get ahead of itself, but if Ingenuity is a total success, how soon do you think we could see another helicopter on Mars? I guess this would be for Lori or Bobby. I'm wondering if NASA would seek to add a new mission for that, or is it possible that the sample return mission could add an aircraft? Thanks.
I can take that one if you like, to at least start, and then maybe Bobby might want to expand. But from the NASA perspective, I think this is going to be really, like I said, an enabling capability that we're going to demonstrate, hopefully with the flights over the next several weeks. As far as identifying a specific opportunity in the near future, what we like to do within NASA is to provide competitive opportunities to our community. And so we do offer those on a periodic basis, and would hope that the community will see this as a great opportunity to start thinking about aerial platforms as a potential way to really expand our Mars exploration. So that's the most likely pathway in the immediate future.
Yeah, and if I could just add to that, it's a very analogous situation to when Sojourner first flew and did its thing on Mars. At that time, Spirit and Opportunity were not in the plan, but after the Sojourner's success, which proved the ability of surface mobility, there was a change in plans and an evolution in people's thinking. And it's quite possible that we could have a similar evolution here, where future autonomous aerial systems could come into play.
Thank you for your answers. Up next, we have Mike Wall from space.com.
Thank you all for doing this. Just a quick question. Is that 31-day kind of mission length for Ingenuity? Is that a hard deadline, or is there a world that where you could see Ingenuity operating beyond that? And if it performs really well on those initial flights, actually doing some work for Perseverance, helping it scout and so forth. Thanks.
Bobby, would you like to take that?
Yeah, I'll take that. It's the month of Ingenuity, right? And conduct our technology demonstration and meet all of its objectives in that month. We also have a science mission to conduct, a very important science mission that's going to gather the samples that will eventually come back to Earth as part of the Mars Sample Return Campaign. So that month is our window to conduct the technology demonstration experiment, and we're confident that we.
Thank you, Bobby. Up next, we have Irene Klotz from Aviation Weekly.
Thanks very much. My question is for Bob Balaram. You mentioned the flight testing in the chamber, of course. What do you think is the riskiest part of actually flying this on Mars? Is it dust, or is there some other element that obviously you couldn't test for on Earth that kind of has the team most curious about what's going to happen?
Yeah, I think the biggest challenge will be that we are flying in the atmosphere of Mars, which has its own dynamics, its own winds, wind gusts and so forth. And these are things which we tested with wind tunnels in our chamber. We have some confidence that everything will be good, but there's nothing that beats actually being in the real environment of Mars to actually see how well the flight in the aerodynamics actually works out. There are also other challenges related to surviving the night. We have a thermal system for this very small system, which is it's difficult to keep a small system warm through the night, as you can imagine. And so just to see how well that thermal system protects us through the night, how well does our solar panel work? There are a number of engineering aspects before we even get to the flight. But when it comes to the actual flying, it's really the winds and the dynamics of how all of that interacts with
Perseverance backs away from it. Thanks.
I can take that. So we are learning more and more about the specific winds and atmosphere and temperatures and how dusty the place is, how much. So we're getting a lot of information that is helping us finalize our plans. But there is really no concern in the sense of anything blowing over. The forces are really quite small in terms of having the helicopter topple over when it's on the ground. So really all the challenges are related to aerial flight, and we will get more information all the way up to the day of the flight. forecast team that is telling us every day what the winds will look like as to the best estimate and the best knowledge. We will know what the solar power looks like during a commissioning phase. So we'll be fully prepped up for that first day of flight. And right now things are reasonable. There's nothing that stands out as a unique challenge or a unique hazard in anything.
Thank you. And up next on the phone lines is Issam Ahmed from AFP.
Yeah, hi. Thanks for taking my question. Mine was about that most perilous phase, which Farah Alibay described. What might happen? Could you just dig into that a bit more about what the issues are and what might happen if Ingenuity doesn't get the charge it requires? So does it just die then? Is it irretrievable?
Yeah, sure. So that last sort of stressful phase that I was talking about is the deployment of Ingenuity to the ground. So think of it as Ingenuity is vertical below the rover, and we separate its last connection to the rover, and that's the connection that gives it energy, that keeps it warm overnight. So that timeline that I talked about is 25 hours in terms of how long our batteries will last from our models without getting any sunlight on the helicopter. So from the rover point of view, that's a reasonable timeline. We're not talking about, we just have to drive 5 meters. It's something that we do every day on Mars right now, but still, we are giving ourselves as many shots as we can to get that drive off because it has such huge. So what we're doing is that we're dropping the helicopter on the ground. We're actually going to have ground in the loop. Us humans here are going to be able to interact and see what happened with that drop, and then we'll command a drive away from that helicopter. If that drive doesn't happen on that day, we as a team will have overnight to debug and to figure out what happened and drive off the next morning, and Ingenuity will still be okay. We have a great team of engineers, and I'm sure that whatever Mars throws at us, we'll be able to deal with it. And we sure have practiced a lot for that day to make sure that we get Ingenuity safe on the ground.
Thank you.
I can add a little bit to that. As long as they do get off eventually during the next day, we have a pretty good chance of charging up a battery. It may not be a full day of charge, but it'll be partial. So if there's any delay over and beyond 25 hours, it's not necessarily that, but that's what the team is making sure that we don't get shaded under the rover for that longer time. But if they can get off the next day, even if it's a little bit late, we should be okay.
Thank you for your answers. And we have social media questions coming in as well. On YouTube from Gaming Nerd 353 asks, how high do you think it will go up in Mars' atmosphere? And if it works, how will it help in future missions to Mars? Håvard?
Yeah, so the first flight that we're going to do that I talked about earlier, we're going to go 3 meters high. And then our nominal flight out height for the remaining flights is 5 meters above the ground. So that's mostly where we're going to be. Now, as far as the potential that this has for future exploration, you can kind of think of it as, we use drones and helicopters here on Earth for all sorts of things that they're more suitable for than land-based vehicles, right? So you can just imagine being able to have that same capability on Mars, flying around on Mars. And that could be for reconnaissance purposes, taking pictures to scout out areas, potential science targets for future rovers or even future astronauts on Mars. Or it could be carrying its own science instruments into areas where you can't get with a land-based vehicle. So that's the kind of potential that this technology could have for the future.
And Håvard, for our American audiences, could you convert the meters too, please?
Yeah, so it's about 15 feet is the height of the most of the flights.
Great, thank you. And up next on the phone lines is Robert Hotz with the Wall Street Journal.
Hi, can you hear me all right?
Yes, we can.
Great. So I thank you for the briefing. I have 2 questions. And the first perhaps to Bobby Braun. Can you just give us a program cost for Ingenuity, separate from the overall mission cost of Perseverance? Number one. Number two, and as a subset of that, can you give us any idea about the development cost of these remarkable helicopter blades that you all have developed to handle the very thin Martian atmosphere. So number one, the cost question. And then number two, is there any technology transfer or relationship in an engineering sense between the development of the rotorcraft for Mars and the development of the rotorcraft or hovercraft that's being prepared for the Dragonfly mission to Titan? Thank you.
So, yeah, I'll take the first question, and then I'll turn the rest over, I think, to Bob. But the program cost for Ingenuity was on the order of $80 million, and that's separate from the Perseverance cost itself. Bob, do you want to talk about the blades and their design?
It's a little bit difficult to separate out, a particular element because this design was done in a very integrated, holistic sense where a lot of engineering trades across multiple subsystems, power, blade design, fuselage design, thermals. So it's very difficult to isolate the cost. So I don't think there's an easy way for anybody to come up with an answer as to what the particular blade, technology work ended up costing. With regard to your second question about Dragonfly, so yes, we have been in conversations with them. They've been especially interested in getting some of our early thoughts on what kind of testing we did. After all, part of the invention here was not only to build Ingenuity, but to build a test program for a first-of-a-kind system. There are no, places to go to sort of look up what should you test next. So they have, some of the engineers have been in consultation with us as to what kind of testing would make sense. So we have given them some of our inputs. And so that's the nature of the interaction at this point. And I'm sure as their program matures and they go into other phases of their development, there will be folks on the Ingenuity team who will be able to offer help and guidance to the extent that we can.
And we can also get Lori in here. Lori, would you like to answer some of the questions as well? And we can also get it repeated for you.
Sure. No, I'll just expand a little bit on Bob's comment there. I'm really glad to see, across NASA, we like to learn from each other, and we've got this great experience and expertise here from the Ingenuity team. And of course, the Dragonfly team is just getting started on their development of working on the quadcopter, the large rotorcraft that they're planning to send to Titan. It's going to be really interesting to see how this kind of capability will scale up. Of course, there are similarities and differences between both of the different flight systems. And of course, the environments are very, very different. But I think, what we learn from this experiment will definitely feed forward, and really happy that we're, having this ability to take the information that we learned from one mission and move it on and take that to the next mission.
Thank you, Lori. And we also have costs in the Ingenuity press kit that is available online as well. And up next on the phone line is Bill Harwood with CBS News.
Yeah, hey, thank you. I think this is probably for Bob. Is the limit, the 5-meter maximum altitude, is that just based on general principle being safe, or is there anything to do with the nature of the Martian atmosphere that makes you not want to go higher? And a second question, real quick, if the device flips over on its side or something during the landing, would it even be possible to use the rover and its robot arm to maybe come to the rescue and flip it back over, or would that just be all she wrote if something like that happens? Thanks.
Yeah, let me ask Håvard to comment on the height limitations, and then I'll get back to the flip over question.
Yeah, so the nominal height of 5 meters is, there are a couple of factors there. One of them is that we have a laser rangefinder that measures the distance to the ground. And we've characterized that up to a certain range, and we want to have, a sufficient amount of margin on that so that we're completely safe for our nominal flights. So that's part of where that comes from. It's not really the atmosphere. The helicopter, physically would be capable of attaining higher altitudes, and it could, in principle, go higher, currently as designed. And there may be cases where, if everything goes well during our nominal flights, where we might stretch things a little bit beyond, the nominal heights.
Yeah, and regarding the question, if for whatever reason there is a unfortunate case where the Ingenuity doesn't land quite right and, tips over, it's quite likely that the damage, especially to our blades, will be such that it really doesn't make sense to, try to do anything further at that point. So there really is no merit to actually having Perseverance come back and right-side it up. It would most probably be, it's really not flyable. Of course, it's all been designed so that it have that expectation, unless it's a really bad day during the test flight program.
Great, thank you. And up next we have Leonard David from Inside Outer Space.
Thanks very much. I think we touched a little bit on this, but maybe for Bobby, and thanks for being here in Boulder. I appreciate the nod to the community. Kind of a device like this being used in an astronaut toolkit. I mean, what kind of range might be possible given a successful test of this demonstration? And then the other thing is, how long-lived is this vehicle, and is it conceivable that it could be used in the Mars sample return program?
Okay, that was to me. Thanks, Leonard. So, as you know, we have robotic assistants that are paired with astronauts today, like on the International Space Station, for example. And so there has been quite a bit of work done in how humans and robots could work together for exploration purposes. We've been pathfinding some of that on the International Space Station. But certainly, as humans venture out at some point, you could imagine that occurring. I dropped the other part of your question. I apologize.
How long-lived would the vehicle be, and is it conceivable, if everything is still operational on it, can it survive for years before the Mars sample return mission gets underway?
Yeah, so I'm sorry. Yeah, let me address that. It's not conceivable. Let's just be straight about it. Sojourner, by the way, lasted about, if I remember right, it lasted about a few months on Mars. It was a tech demo, right? And it did not have the long life that Spirit, Opportunity, Curiosity, and we believe Perseverance will have. And in much the same way, this is a tech demo. It's been sent to Mars to prove the capability, and we believe we can prove that capability. We can meet all the flight test objectives in the month of Ingenuity. So there's not really a need for that long life. It hasn't been designed for that purpose, and so there's really no way I could conceive that it could last through the harsh conditions on Mars for the length of time it would take to participate in some future mission.
Okay, thanks so much.
Thanks, Bobby. Lori, would you like to weigh in on this question as well?
I think Bobby's done a really good job of answering both aspects of the questions. I'm not sure I have much to add, but as a technology demonstration, it's designed to last as long as we need to prove out this incredible capability.
Great, thank you. And up next is a social media question. Akashan on Twitter asks, when can we expect to see some results, videos?